Okay, now let's see how we can leverage the Istio service mesh to access our services through Kayali dashboard. Okay, before that, let's make sure everything is running just fine. So for that, what I'm going to do is I'm going to say kubectl get all. So this is going to give me all the resources that are currently running in the cluster. Okay, the moment I do this, it's going to give me all the replica sets, all the deployments, all the services, and all the parts. Okay, everything looks good so far. And also we can access this load balancer URL to access our application. Let's check that as well. Let's refresh that, and everything seems to be running just fine. Okay, now what we're gonna do next is we're gonna install istio-ctl in our local machine. Okay, so for that, what we're gonna do is we're gonna go to this URL. That's where we have all the packages for istio. Let's go here, and from here we can choose all the packages that we want for our system. So so for mine, I'm going to choose this one. So basically I'm going to download this and unpack this, and then copy it to the working directory. Okay, that's where we have all our manifest files. Now let's see what this looks like. First of all, let's go to VS Code, and if we go inside this VS Code here, in our working directory, now we have something called a folder called istio with the version. Okay, now if I expand this, I have something called bin, and this is where istio-ctl is. Okay, so, and if I expand samples under add-ons, I have all these YAML files. Okay, so if I go here under kayali.yaml, so this is the manifest file for Kayali dashboard. If we apply this file in our cluster, then we can access Kayali dashboard. Okay, that's what we're gonna do. Now for your system, maybe you might run into some problems. So for that, what you can do is you can basically export path to this bin folder. That's where our istio-ctl is. Okay, so once you do that, everything should work just fine. Okay, now it's time we install istio-ctl in our cluster. Okay, but before that, let's see what are the namespace available in our cluster. Okay, let's go here, and I'm going to say kubectl get ns. So this is going to give me all the namespaces that I have here so far. So as of now, I just have 4 namespace. Okay, and all our pods, deployment, replica set, and services are running under default namespace. Okay, now let's see, let's install istio-ctl. So istio-ctl install. So this is going to install istio in our cluster. So I'm going to proceed this with S. Now let's see what happens. Okay, so it should basically have a few more namespaces added. Okay, so let's go here and see. So this would basically add this istio system namespace to our cluster. Okay, let's check that. This is done, and let's do kubectl get ns again. Now we can see that istio system namespace is added. So this namespace is basically, this is going to contain all the resources related to istio service mesh. Okay, so if we do kubectl get parts under this namespace, we can see this istio-d. So this is like a control plane for istio. That's one part that's running there, and ingress gateway is another part that's running. Okay, we can do the same thing for services that are running inside istio system. If we do svc, as of now we only have the ingress gateway service and also istio-d service currently running. And so now what we are going to do is, let's go back and check this document here. Now it's time we inject this proxy services to our pods. Okay, now but the problem is our pods, let's say kubectl get pods kubectl. Okay, so these are all the pods that are currently running in our default namespace. And then we have another namespace called Stio system, right? Now we need to add label to our default namespace. So if we check the labels that are currently available under default namespace, let's do that. Okay, so for that, what we're going to do is kubectl get ns. So if I say kubectl get ns hyphen hyphen, so label, right? So this is going to show me all the labels that I have here so far. Okay, is this the correct command? Okay, I didn't specify the namespace, that's why. Okay, just a second here. Get namespace, and the name of the namespace is default, right? So as of now, we only have this label. Now we need to add one more label called istio injection enabled. Okay, so for that we can run kubectl label namespace default istio injection enabled. Okay, let's just do that real quick. Okay, and this is going to be kubectl label. Okay, the moment I do this and check the labels on default namespace, I'm going to see one more label added here. Okay, now if I do, so let's do kubectl get pods. So right now I just have one container running in my pod, right? Now if I reapply this manifest file, I should be able to see two containers running in a pod. Okay, so for that, what I'm going to do is I'm going to say kubectl delete everything first of all. Okay, let's delete the previous deployment, and then let's create a new deployment. So when we create a new deployment, there should be one additional container attached in every pods. Okay, let's check that. Let the deletion be completed first. Okay, the deletion is completed. Now let's say, now let's do the deployment again. Okay, now the moment we do this deployment, let's check these pods again. Okay, get pods. Now you can see that there are two containers running in each of these pods. Okay, so some of them are fully initialized and some are in the process to initialization. So that means we're able to inject these sidecar proxies to our pods. Okay, let's run this again and then make sure all these pods have this sidecar injected. Okay, let's rerun it again, and looks like the load generator and add service, except these two services, the sidecar proxy is injected in all the pods. Okay, now let's rerun it and make sure. Okay, so now we can see this, all the pods have sidecar container injected. Okay, now also one more thing we can do is kubectl get pods under the namespace istio system, so it's the same, right? And also we can check the services that are in the istio system. Okay, and this is also same, we already checked this. Okay, now it's time to access Kayali dashboard. Okay, for that, if we go inside this working directory here, under this folder samples add-ons, we see something called Kayali .yaml, and also there are other manifest files for Grafana, Geiger, and Loki, Prometheus, and things like that. And even inside extras we have other Jipkins and other configurations. So let's apply these configurations to our cluster so that we can access the services through Kayali dashboard. Okay, so for that, what I'm going to do is I'm going to go back to the terminal, and let's do kubectl. Okay, first of all, let's do cd, or we can do something like this. We can do it from here as well. Okay, so keep ctl apply -f, and then from there, so istio samples and add-ons, right? Because we have everything inside add-ons, so we're going to apply everything that's inside add-ons, right? Now the moment we do this and press enter, now this is going to create other service config maps and deployments. Okay, now if we do get services inside istio system, we're going to have too many services running here. If we do get pods, so initially we just had this ingress gateway and istiod. Now we have pods running for Grafana, Jaeger, Kayali, Loki, and Prometheus. Okay, now let's check the services inside istio system. So, and for the services as well, there is a lot of other additional services added. And for now, we're interested to access these services through Kayali dashboard. But if you see here, this service is running on port 20001, and the service type is cluster IP. Okay, because there is no external IP, we cannot directly access this in our local computer. Okay, but we can access this using a technique called port forwarding. Okay, for that, what we can do is we just need the port number of the service that we want to forward it to our host machine, and also the name of the service. So the name of the service is Kayali, and then the port is 20001. So what we can do now is we can say kube ctl port hyphen forward svc, short for service, and then the name of the service, and hyphen n within the istio system. So that's the namespace, that istio system, and the port number. Okay, if I do this and press enter, now this is going to forward this port to our local machine. Now we can access this using our local host. So just copy this, let's go here and let's open a new browser tab and then paste it here. Okay, now we can see this, we have a beautiful dashboard given by Kayali. Okay, so this is the default namespace we had in our cluster, and then we had another cluster called istio system. Okay, and let's see here, and within istio system we had 4 applications. Okay, let's just go back and see. Let's see here. Okay, the pods you see here, so that we have 4 pods running right initially. So, and within the default system we have 12 applications running. Okay, now we can even check other things from here. Let's go back to the traffic graph. Okay, that's the graphical representation of our services. Now so this is, if you put your mouse on top of it, it's going to tell us what service this is. So this is a front end service, right? And then if we go here, this is add service, and then this one is checkout service. So all these services you can visualize from here. And if we go here and check a few other things here, maybe traffic animation. So this is going to show us how the traffic basically traffic flow happens in our application. So we're going to receive the request here, the load generator is going to generate the load, and then it's going to go to the front end application, and from the front end application, so the traffic is going to go to all these other microservices. So this depends on the logic written in microservices. Okay, so this is really interesting thing. Other than that, so there's so much thing that you can do here. You can also check all these response times, traffic distribution, and all this. So you can play around with all these options available here. And if you go inside these applications here, you can see what is the health of each of these microservices that are running in our cluster. So right now you can see all the microservices and the namespace that the microservices are running in, and the labels. When you write manifest file, so these are the labels we specified, and this can be visualized here. And all these application pods are healthy. So, and from here you can select other things as well. let's see here, and if I say not present, probably it's not going to show anything because all the application have sidecar present inside them. Okay, this is how we can sort and filter from here and check if any of your microservices is missing the sidecar proxies. Okay, we can go to workloads and visualize even more features from here. Okay, so let's see here. So this is missing version. Okay, version level is missing, so probably it's talking about the manifest files. And if we go to services again, so this has even more features here. Let's try to see if we can go inside one of the service. And so this is like the tracing, okay, the traffic flow from front end to add service and things like that. Okay, so let's go to istio config, and from here let's see. Okay, probably we can give our istio name and get the details about that. And so this is another representation of our Kubernetes cluster that has istio-d. So that's like a control plane for our istio service mesh and all other this visualization options that are there. Okay, so this is the brief overview on Kubernetes. So we just looked at one of the features called service discovery using a tool called Kayali, but then we can leverage all other add-ons. So if we go here, since we have applied all these add-ons to our Kubernetes cluster, we can do port forwarding on each of these services and access this in our local machine and check how our cluster is behaving. Okay, so that's about it. And so once we're done, we can basically stop all these services and then delete the cluster. Okay, because these are B-level service. So for that, what we can do is we can do delete the all these Kubernetes manifest files, and then we can also delete the cluster. Okay, so for that, what I'm going to do, go here to our terminal. I'm going to cancel this. Let's do kubectl delete -f kubernetes.yaml. Now this is going to delete all the deployments that are there internally, and then let this complete. And after that, we can also delete the cluster. So in order to delete the cluster, we're going to use the EKS ctl command. So it's the same CLI tool that we use to create the cluster. Okay, so let's give it some time. Okay, it's done. Now let's do EKSCTL delete cluster, and then the name of the cluster. Probably we don't need to specify the node group, and this simple command should actually delete our all the resources that were created. Okay, so that's it for this demo. If you have any questions, just feel free to write your questions in the comment section, and thank you for watching.